Okay. Yes, there is. I got to be honest with you. There's more to physics than putting blocks on sliding things. Okay, there really is. But let's just go ahead and take a look at this problem because it's asking for a lot. It says a box of mass of 12 kilograms rests on an inclined plane with a coefficient of static. Because we're going to do the same type of problem later on when we get to energy, and it's really kind of cool how when we work in energy, it makes this problem much easier. Okay. All right. So anyway, the and it has a height of 3.2 meters at its tallest point. Okay, we've got all kinds of data here. We've got the coefficient of static friction. And what angle does the plane make with respect to the with the coefficients between the block and plane? The inclined plane is L, and it's at its tallest point. Okay, so part A. What angle in degrees does the plane make with respect to the horizontal? Okay. Oh, that's like, well, you tell me. All right, so they're setting us up. Hey, they told you the height, and they told you this length. So I think a little inverse sine action would help here. So on problem 8, let's go ahead and look at problem 8 real fast. Problem 8. Oh, I'm using a different pen now. Problem 8 on homework number 6. You got this situation. They told you this is 4.4 meters, and this is 3.2 meters. They want to know this angle. We can do that all day long, right? No problem. So we'll come up with that. So you know how to find angle theta. Little inverse sine action there. All right. So now, let's keep looking. What is the magnitude of the normal force in newtons that acts on the block? Oh. Well, we know the because they gave us the mass of the block. We know gravity. We know all that. So in other words, what we're going to do is we're going to do this. Got to find the normal force. I kind of like this problem because this kind of we get a chance to kind of like rehash the whole thing. So here's the block sitting here, and it's got mg going this way, and it's got a normal force going like this. Okay, and then it's got this angle, and GC is made up of these two vectors. So the sum of the forces in the y, and I'll do like the book does. We'll call, when it's cattywampus like this, we'll call it y bar. But I don't like doing that. I like let's crank this sucker down. Here's angle theta. Let's crank it down to here. Make it flat. Then we got the normal force like this. But what happened to gravity? It's coming out here cattywampus like this. Okay, and I think we've talked about this already. This is all coming back to me. Okay. All right. Now, it's at rest. So its acceleration is equal to 0. So the sum of the forces in the y direction, we'll go back to that sum of the forces in the y direction, in the x direction, and the sum in the y direction is always equal to 0, so for our purposes. So what we have, we've got the mass of the block times 0 is equal to Fn minus, what is this vector right here? If I know this is theta and I know the hypotenuse here, this is the adjacent leg, minus mg cosine theta. We did that already. We did that today. So that's nice. So you know that Fn is equal to mg cosine theta. It's not always going to be that way. But for if you get a sliding block problem or a skier going downhill, it's going to be that way. Okay, and so now they told us what mu of s was. This was given. So now I know the strict. There you go. We got that one answered. Oh, they wanted the magnitude. Oh, well, we got that too. What is the force of gravity along FGX? Okay. All right, now this is crucial. All right, so here we go. I'm going to be an American in a foreign country. We're going to do this slower and louder. In other words, I'm going to draw the picture even bigger. All right, so here we go. So let's take this little inset here. All right. So here I had mg cosine theta. Here's mg. mg sine theta. Now, which is my acceleration in the x direction? Right, this guy. I don't mean to tell you how to suck eggs, but we needed to go through. Write expression in terms of theta for the magnitude of the force due to static friction. Oh, we already did that. We've already done that. In terms of theta, there it is. Static frictional force is equal to mu of s times Fn, which is equal to mu of s. Now they want it in terms of this, so it would be mg cosine theta. Piece of cake. We can do this all day long, right? Okay. Party, will the block slide? Ah! Will the block slide? There's enough information. You figure that out. In other words, is that static frictional force? The static frictional force is greater than this force. Oh, you don't know what I'm pointing at. If this guy, because now look, here's what's going on just in the x, y. You got mg cosine theta, or mg sine theta going this way. You got the static frictional force. When will it slide? When mg sine theta is greater than f of s. That's when it'll slide, or right when it's greater than or equal. Right when it's equal to is when it starts to slide. As a matter of fact, you can also go, well, whatever, if tangent of the angle is equal to the mu of s, believe it or not, where it starts to slide. So that's kind of a nice little bonus thing you just learned. All right, good. Let's stop here. Look at some more.